Okay, get started in about a minute. About a minute. Jace, did you get your question answered? All right. Hopefully you guys took your test. I know I talked to a couple of you. Some of you had questions like, oh my word, there's one that the number is crazy large. One, well, then I know you used your calculator. Two, then I know you didn't understand how to solve the problem. For that one where it looked like you're going to have to multiply 25 times 24 times 23. Well, if you set the problem up correctly, you would have noticed that everything cancels with the exception of three numbers, and it wasn't as bad as you thought. So for those of you that were doing this on a calculator instead of doing it by hand, yeah, you got something crazy because you didn't know what you were doing. However, for those of you that set it up by hand, then you would have noticed that, look, almost everything cancels with the exception of two numbers. I'm not going to explain it to you now because maybe there might be some people that still haven't taken their test, but I will explain it to you probably tomorrow. All right, we're starting chapter 12 in the book. Chapter 12 in the book. Chapter 12 in the book is going to get split up by the CMAS testing. I thought it was going to be chapter 11, but it turns out it's going to be chapter 12. We're going to do 12-1, 12-2 today, tomorrow, 3-day weekend, come back on Tuesday. When you guys finally come back, the Monday after next, then you're going to have, this is for 8th graders. Jace, I don't know about what yours is. I assume it's just going to be 2 days since you want to take your, you're taking your math test, I think?
No, we already took them. We took them all before we left.
Then I have no idea what you're going to do while we're doing the CMAS. Maybe you're just going to be with me hanging out, probably. But the 8th graders are going to be taking their CMAS 2 days or 2 tests a day. It's going to be a full day, 1 in the morning, 1 in the afternoon. You have to take 3 math tests and 3 science tests, so 2 per day. Believe it or not, this is into May. And just so you understand what's going to happen, the last week is our finals week. So you take your finals, that's the whole week. The last week of May. The week before that, I stopped teaching on Tuesday, and then we review Wednesday, Thursday, Friday for semester finals. So really, there's only 2 weeks, and you're seeing one of them this week of CMAS. That's the first week of May. The second week of May, and we'll finish chapter 12, but there won't be much left to do. In other words, what I'm basically trying to say is we're almost done with the book, and here we go. I like this chapter. Here's your homework. This chapter is on basically statistics and graphs and whatnot. I mean, we've already done the graphing lines and stuff. This is going to be doing your graphs, you know, your bar graphs, your line graphs, your stem and leaf plots, your box and whiskers, your histograms, all of those. Now, if those are words that you have no idea what they mean, great. I'm going to teach them to you this year. So 1 through 11 all. Okay, it starts off really simple. Maybe Jace, you might be the only one. I don't know if you've seen these before, but if you get to 8th grade and you've never seen a bar graph, there's something going on wrong. All right, and even if it wasn't in a math class, you see bar graphs in English class, you see them in history class, you see them in science class, you've seen bar graphs before. All right, so this chapter, it's basically on graphs and statistics, as I said before. A couple quick vocabulary words to put in your notes, so make sure these wind up in your notes. The only bad thing about doing this via e-learning is that I can't give you the graphs themselves they're going to appear on the screen right here. So normally I'm going to give you a piece of paper that has the data or the statistics or the graph on it. So this will be a little bit cumbersome to do this via e-learning, but it's not impossible. So in your notes, today we'll be talking about data. Now, some people pronounce it data. Either one is fine, data or data. By the way, the plural of data or data is data or data. It is both a singular, it's like deer, right? Deer is both singular and plural. Data is both singular and plural. So sometimes when people talk about the plural form, the sentence sounds weird, like the data are. So when you hear the data are, they're talking about plural. When they say the data is, they're talking about a single set of data. All right. But basically data are facts about objects. I mean, literally facts about objects. They could be numerical facts. They could be other facts. For instance, what's your favorite color? That's a piece of data, right? That's not a numerical piece of data. That's a categorical data. All right. Non-numerical, as I said. Sometimes you can have numerical data that's actually non-numerical. For instance, if you thought about I don't know, sports jerseys. So on a team, you know, the center, I don't know if this is trying to play basketball, football, the quarterbacks all get, you know, basically the same kind of numbers. The number that's associated with a quarterback, it's a number, but it doesn't really have a numerical sense. Like you wouldn't do adding, subtracting with those numbers. You don't add the jersey numbers and get some meaning behind it. However, the number has meaning behind it. So there's sometimes even numbers are considered non-numerical in that sense. And we might see an example of that or two in this chapter. In a broader sense, what we're going to be doing in this chapter is statistics. And statistics is the process of organizing, arranging, and interpreting data. So we gather data about something. Well, that's great. We got a whole bunch of numbers or non-numerical data. Hey, I've got everyone's in class favorite color or favorite dog breed, right? Or how old they are, or how tall they are, right? That would both be numerical and non-numerical data. If I want to get some meaning out of that data, I'm doing this thing called statistics. And that's where I take all that data and I organize it and I somehow get an interpretation of it. And this entire chapter is about that process of organizing and interpreting the data. How to, the main technique we use to interpret data, some people can literally look at a stream of numbers and they can figure something out by looking at a whole bunch of numbers. Most people need it arranged for them visually. And by that, I mean, they have to graph it. So it's a method of visually arranging the data. In other words, we kind of get rid of the numbers and we get a shape. And the shape has meaning behind it. And most human beings can understand data by looking at shapes, believe it or not. I've always told my students, of the things that you will do as an adult, mathematically speaking, besides arithmetic, add, subtract, multiply, and divide, statistics is the next most main thing that you do with numbers as an adult, no matter what your job is. Many of you will never, ever, solve an equation ever again in your life once you get out of high school, college. But all of you will add, subtract, multiply, and divide, and all of you will interpret graphs. And that's basically doing statistics. Okay, here's an example. Here is a, I don't know, they gathered some data about what's the outside temperature. This is in Celsius, so it's harder for us to understand. And how much ice cream was sold that day. Now, if we look, it's organized, it's in a table, but most human beings look at this table, their eyes glass over, they look at the numbers, and they're like, what in the heck is going on? The data is right there, and the interpretation is right there in the numbers, but it's hard to tease that information out. So what statisticians do is they present the same numbers just in a different form, and that form is with a graph. So here is one of the ones that we will be doing this year. This is called a scatter plot. You may or may not have seen this before. But there's all that data plotted on a graph, and somehow we're supposed to interpret, well, if I just look at the dots, it looks like the dots are rising. They're getting large or getting higher on the graph. And if I look at the axes, it says temperature. So basically, as the temperature increases, the amount of ice cream that's sold also increases. That kind of makes sense. Some of you would say, I don't need a graph to tell me that. I would know that. But that's a pretty good example of why we would graph data. Every human being should be able to look at that graph that has some sort of mathematical education and be able to interpret that graph. Only a few of us could be able to look at the table on the left and get that same interpretation that, look, as the temperature increases, so do the sales of ice cream. So this chapter deals with data, graphing data, and then I guess most importantly, interpreting that data. We will do a bunch of things. Today we're doing bar graphs. We will also do line graphs today. And then we get to probably some of the ones that you've never done before. Stem and leaf plots, box and whiskers, and histograms. So these three right here are probably the ones that you haven't done. I don't know, maybe you have. But some of you I know probably, and histograms are the most widely used graph that you will see as you go into higher education. And those are the ones that we'll probably spend the most time on, the histograms. All right, so these could be new to you. No big deal. So we're going to do bar graphs and line graphs today. So also in your notes, write this down. What the heck is a bar graph? So a bar graph is it's you're graphing data, and the way you graph data is you use bars. You've seen these before, but what you probably haven't been told and what you probably haven't paid attention to, that generally speaking, bar graphs are used for non-numerical data. In other words, if I want to make a graph of everyone's favorite color, colors are not numbers. I would probably use a bar graph. Bar graphs are generally used when the data is not about numbers. What city are you from? If we ask every single person in the United States what city you're from, we could probably do a bar graph, and the bar graph would show which city has the most people. But asking you what city you're from is not a number. All right. So that's its purpose. I mean, it's almost, you can use it if you have a numerical data, but we have other better graphs for that. But it's almost always used to indicate patterns for non-numerical data. And I'd use that word categorical data as well too. You know, what's your favorite color? That would be a category. What's your favorite animal? That sort of thing. Okay, so today we're going to be doing bar graphs and line graphs. So notice once again, the previous one I gave you was numerical data. We both had a temperature and we had ice cream sales. Both of those involve numbers. The ones we're going to be doing today, well, here's an example of a bar graph, is we ask, what's your favorite fruit, right? Fruit is not a number. So here's a bar graph, and you've seen these before, and you're like, well, there's numbers there. It says the number of people on the left, but the categories of fruit are not numbers. So what I'm basically saying is, if your data has two sets of numbers, we're probably not going to do a bar graph. But if your data has one set of numbers, right? And sometimes those numbers are not even apparent. If I ask everyone, what's your favorite color? I'm not getting any numbers out of that. It's only when I make the graph that I get numbers. All right, there are parts to a graph. By the way, I should also point this out. Graphs, right, of statistics, generally speaking, are all done in the first quadrant. You may not know it, right? But we're really in quadrant 1 of the Cartesian coordinate plane, right? Sometimes you can get negative numbers and we get into quadrant 4, but mostly we're in quadrant 1. So what I'm basically saying is, if you can imagine this as a coordinate plane, I still have the origin, but I'm really in quadrant 1. Occasionally you can get negative numbers, but we almost never wind up in quadrant 2 or quadrant 3. We're always either in quadrant 1, or sometimes when there's negative numbers, we get quadrant 4 as well too. So we don't make the full Cartesian coordinate plane. We just basically almost always just use quadrant 1 because the numbers are usually always positive. There's some cases where that's not true. All right, so the parts of a graph, of a bar graph. Well, let's see what we got here. We got a vertical axis. One, it's scale. That means I just don't have random numbers there. It starts at 0. It goes up in a positive direction. You can go by 1s. In this case, they're going by 5s. It's kind of up to you. You've probably seen this before. Breaks are allowed. I'm not going to talk about breaks right now, but I do want to mention that's part of it. If you know what a break is, so I'll say it right now. So for instance, if I took a poll and it's out of a lot of people, and all the numbers start at 400, well, you probably don't want a bar graph where you start at 0 and then you go by 5s. You may want to have a break and start at, I don't know, 200 or something like that. Not 200 at the origin, but 200 as your first tick mark. We also always have a label, and let's see, our label here is the number of people. So that's your vertical axis. Well, we also have a horizontal axis. Notice for bar graphs, since it's categorical data, right? Non-numerical data, right? Well, I mean, I guess I could put them alphabetically, right? But there's no rhyme or reason how you place these, right? So there's no scale or arrangement. You can put them in any arrangement that you want. It doesn't make a difference. The bars that you actually draw, hence the name bar graph, the bars show the data. For instance, Apple, there's 35 people that said that Apple was the nicest fruit. All right, there's also a label here as well too. There's also spaces between each bar. And you're like, well, why wouldn't there be spaces? You're going to find out when we do a graph called a histogram that there are no spaces. And histograms are not for non-numerical data. It's when it's numerical data. So bar graphs, you can tell it's a bar graph because there's spaces in between the bars. And the x-axis doesn't have numbers. It could. For instance, if I said, what's your favorite number, right? We probably would have, instead of Apple, it would be 1, 2, 3, that sort of thing. So there could be numerical numbers on the bottom, but once again, they're just categories. They're not, well, we're not doing anything with those numbers like add, subtract, multiply, or divide. All right, and then lastly, all graphs have a title, right? So that the person understands. Now, if it is unclear about anything, you might have another box that indicates what things mean, right? If it wasn't very clear, right, you might have a separate box that showed you what things meant. And I'll explain that a little bit better as we go on. So our job is to make bar graphs tonight for homework. So first and foremost, if you're lucky, they're going to give you data that's already in a table. If you're not, then step number 1 is you got to put the data into a table. Step number 2 is you try to figure out, well, what do you want for your vertical axis? In other words, well, it starts at 0, but do we want to go by 1s, 2s, 5s, 10, 100, 1,000? Any of those are possibilities. You got to figure that part out. Step number 3, once all that's done, is you make your graph. And there's no step 4. That's it. Now, when making the graph, would include labeling as well and all that jazz. So, like I said, this doesn't work very well when we're doing this in e-learning, but what I would like you to do slowly, carefully, methodically is to make a graph of this data. Now, I was nice to you. I already put the data in a table. So let's see, we got to make a graph of this right here. We got to make a graph of this right here. Now it does give us a table, so half our work is done. Remember, your x-axis will be your categorical data. So in this case, that's countries. And your y-axis will be in coal production. That will be, notice it's numerical now. How much coal did each country produce? All right, so we got an x and we got a y, x and a y. Now we can make our graph. So before you make your graph, though, we need to figure out, well, we don't need to figure out our horizontal axis. It's going to have the countries, China, Poland, India, UK, United Kingdom, and United States. But we do, for the y-axis, have to figure out what our scale is. Notice the way you do that is you find the largest and the smallest number. So they may not be in order, right? And they aren't in this case. So the largest number is 750 and the smallest number is 128. So I have to have a graph that can at least show 750 and 128. So maybe going by ones or fives or even tens is not a good idea. Maybe going by hundreds is a good idea, right? Or maybe 50s, right? It kind of depends. So Merry Christmas is already in a table. Step number 2, we just figured out our vertical axis. That means what we're going to go by. Step number 3 is we make that graph. So here's my graph. Now I'm doing a bar graph. So I'm going to go by, well, 0 is always your bottom. I'm going to go by hundreds. So if I go by hundreds, that means that's 100, 200, so forth and so on. It is also not a requirement that each line has a number. For instance, I could have skipped the 100, 300, 500, and 700 and just said 0, 200, 400, 600, 800 and skipped. Let me show you what I mean by that. I could have, instead of doing that, now I do need the top and the bottom, but I could have, maybe because it looks cluttered, I could have written 200, skip 1, 400. You've probably seen graphs like this, and then 600. It's entirely up to you. If it feels like your things are crowded, then maybe you want to use this technique right here, because I can still tell that this one in between 0 and 200 would be 100. Okay. If you have enough space and it looks nice and neat, then I would say go for it, put all the numbers, but it's kind of up to you. All right, so we're done with the vertical axis. My horizontal axis has to have what? Those 5 countries: China, Poland, India, UK, and USA. All right, we're doing one at a time, and it doesn't matter the order that you go in there. So China had 750 million metric tons. So I need to make a bar that goes from 0 all the way up to 750. So that's pretty good. By the way, notice there is no tick mark for 50s. If you wanted to, you could. For instance, I could put a tick mark there, meaning each one of these smaller tick marks would be 50. Now you're getting into the realm of, wow, you're probably doing too much work for your graph, but you certainly could. And you've probably seen graphs like this as well too. Okay, so China's done. Now we got to do, we got to label China, right? Somehow we can't forget that the blue means, if that's blue, it means China. A lot of times you will write sideways because sometimes sometimes you might use abbreviation, right? If you do that, then that little box I said to explain things better explain what each one of your abbreviation means. All right, the next country was Poland. It went to 163, so a little bit higher than half. Got a label. A lot of times we like to use different colors. No, you don't need to use different colors, but if you'd like to, you can. Let's see, India was 487. The UK was 128. So what, a little bit less than Poland. And lastly, America was a little bit less than 700. And remember, this is in million metric tons. I made this, the book was produced in the 2000s. So this data is not up to date. I don't know how much coal we make, but China and the United States do rule the roost, so to speak, for coal production in the world. Russia is up there as well too. Okay, we just made our first bar graph. Questions? I gave you 1 through 11. Don't assume that you're making 11 bar graphs, right? You're not making 11 bar graphs tonight for homework. We do need to always make sure we put a title to it and then label, if necessary, our axes. Now, the horizontal axes, since it had the names there, it's already labeled, but the vertical one wasn't labeled, so I got to put a label there. I don't need to put an index because it's clear of what everything stands for. So we're done with that one. All right. Like I said, if this was in class, not an e-learning thing, I would probably spend some time and we would make sure that we all did this one. I'm just not 100%, since I can't physically see your graphs. I'm going to show you what this one looks like. If you're not watching this live, if you want to pause it and make it yourself, you can, and then compare yours with mine. By the way, I'm going to show you a vertical axis. It's my choice of what it is. you can make your own choice as well too. So don't assume that, what, I got mine wrong because it doesn't look like Mr. C's, because I went by ones and he went by, I don't know, fives or something like that. It's up to you what your vertical axis goes by. I will say this, a good graph, the highest data point that you have should go almost to the top if it's a good graph. You don't want to have a lot of dead space. So I probably don't want my vertical axis here to go to 1,000, since the biggest number here is 86. Probably I want to go to 100, and then most likely I'll go by tens. All right, but you can make your own decision there. So let's see, what are we making a graph? This is the exports, how much stuff we send away. So this is in billions of dollars. So it looks like we send a lot of machinery to other countries. And the second biggest one is food. So we arrange our table into data. Merry Christmas. It's already in a table. Figure out our vertical axis. We already did. We said the largest number was 86. The smallest is 10. So I'm going to start at 0. I'm going to go up to 100. And I'm going to go by tens. So 0 to 100. Notice now I'm choosing to, oh, I only went to 90. Notice, I guess I should have reviewed my slides. That'll be perfectly fine because our biggest number there is 86. Many of you probably would go to 100, go by tens. Okay, so let's fill in our data here. Let's see, chemicals needs to go to 21. So we need a bar a little bit above 20. This can be done pretty quickly. Having a straight edge also, neatness does count. If you do it on graph paper, it's ridiculously easy. Food is at the 33. What's the next one? Fuel. Once again, this was data was compiled. I know that we export a lot of fuel, and then machinery is the big daddy of this graph right here. By the way, when there's only a few categories, I don't need a bar graph to interpret this one. Graphs are very useful when you have lots of data. When you only have 4 categories here, it's not too bad. Do not forget to label your axes and your title, and you are done making that. I don't have many of these because these take a while to make, and so we're not going to do any more examples. If you need to see how this is done again, rewind the video, play it again. When you do the one tonight for homework, it's done basically just like this. All right, any questions on bar graphs? Or I should say creating bar graphs. As a quick note, bar graphs don't have to be written vertically, right? They can also be done horizontally. You've probably seen this as well. But notice I still have categorical data, non-numerical data, favorite snacks. Is that a movie? No. Favorite snacks. Boy, it looks like they have an agenda here. I'm going to guess that they're making these data up because I'm pretty sure if I asked middle schoolers that fruit would not be the #1 favorite snack. For you guys, it's probably Takis or something like that. Hot Cheetos or something. Okay, but remember, I guess the point here trying to make is that it doesn't have to be a vertical graph. It can be a horizontal one. And that's not true for all graphs, but it is true for bar graphs. All right, I said we're going to do 2 graphs. I said we're going to do a bar graph and one other type of graph, and that other one is called a double bar graph, a double bar graph. Now, you didn't probably see this in 7th grade, and maybe you've encountered these before. So a double bar graph is a graph that has 2 sets of data about the same categories. In other words, I don't know, maybe they ask girls, what's your favorite color? And then they ask boys, what's your favorite color? And they put both of those data that they collect, they put both of those data on the same bar graph. So they're going to, it's called a double bar graph because for each category, you're going to have 2 bars. So red, is it your favorite color? They're going to have a bar for boys. They're going to have a bar for girls. I've seen these plenty of times. A lot of times they'll have up to, I don't know, even 4 bars. Once you get above 4, so it becomes a very confused looking graph, and sometimes it's hard to understand it. But double bar graphs, you will absolutely encounter these. We use them to compare and contrast, you know, like I said, when you have more than one data sets, but it has to be about the same. I can't have a double bar graph about what's your favorite color and what's your favorite animal, that sort of thing. But if you had two groups or two populations that you ask the same question to, and it's about non-numerical data, what's your favorite color, that sort of thing, then using a double or triple or quadruple bar graph would be a smart thing to put this in. Okay, so here's an example. Like I said, it's a common one for break it up, ask boys a question, ask girls a question. So here's a double bar graph. It's also easy to interpret as well too. It looks like the biggest difference here is pizza and hamburgers, and boys and girls equally like hot dogs. By the way, this is all made up data. Don't assume that this is true. The first two bar graphs we did were true for the year that they were done in. That we probably should have put that in our title too, of what year that data was collected. That would have been smart. So it says Gwen's class party, results of a food survey. It looks like more boys than girls like pizza. I'm not buying that. It looks like more girls than boys like hamburgers. I'm also not buying that. And lasagna, I would expect there to be more people like lasagna. But I would assume that pizza would probably be on top. Usually there's only that one or two kids in class that don't like pizza. Okay, so there's your example of a double bar graph, and yes, you'll have to make one of them. So notice you can kind of see how it's done. Between the two groups or populations, there will be no space between the bars. Between each category, however, there will be space. You see that? So there's space between the pizza category and the hot dog category, but there's no space between the boy and the girl for that individual category for each one. The rest of the bar graph, it's made just as we did the previous one. All right. We do have to finally have that little box that I indicated that tells the reader which bar goes with, in this case, which category, girls or boys. So that little index that you have right there is used to show that. And it can go anywhere, top, bottom. Usually it's just placed in a position for ease of reading for the viewers of your graph. So there was a lot of open space here above here, so that's why they chose that. It equally could have been upper left or lower left or in the margin somewhere, but it needs to go somewhere on your graph. We're going to do one of these, just one of these. So for those of you not watching live or watching the video, pause this, see if you can make this. Play a little bit of it if you need a little bit of a hint. So let's see, we asked some families, and we said to the parents and the kids, we asked them 4 questions or 4 categories. We said, what percentage of your time is spent using the computer to type documents? That's called word processing. What percentage of your time is used for playing games? And what percentage of your time you're spent on the computer surfing the internet? And what time you spend on email? We should have put a category for this year for e-learning. So this is percent of parents and kids. So for parents, it looks like 30% of the time they spend word processing, 5% playing games. They didn't interview me. 40% on the web, and 25% answering emails. For kids, there's the data. So this would be a perfect double bar graph. Merry Christmas, it's already in a table. Let's see, the vertical axis. The biggest number here is 50, right? So maybe going to 100 would be too much. You'd have a whole lot of dead space, right? You can, right? I'm going to go up to 100 and we're going to see all the dead space that I make. So maybe going to 60 would have been better. We'd have less dead space. When I make my double bar graph, the first category was word processing. For parents, it's 30, and for kids, it's 15, right? So there is your parents. Went up to 30. Now, no space for the kids. And there is 30 for your, I'm sorry, 15% for your kids. Now I will put space for the next category. The next category is games. Mine would be about 80%. For parents, it's 5%. I'm not buying that. And for kids, it's 30%. I'm also not buying that. Look at the numbers for web, right? I'm saying kids probably spend more time playing games, especially, let's see, Landon is probably spends 92% of his time on Minecraft. Although he maybe plays it on console, not the computer. If Landon was actually watching this live, we could get an answer to that. Let's see. The next category is the web. So it's not surprising that most people spend most of their time on the internet. And then lastly, email. Just a tiny sliver of kids spend, once again, this is a made up data. This isn't real data. But there, notice all that dead space. And this is why also that we don't like dead space, because it's like a useless, it also exaggerates, it smushes the graphs down because there's so much dead space. We can't really tell what's the big differences there. So try to have as few amount of dead space ever on a graph, and it would be a better thing to do. It's also one of the ways, a couple books, they'll have a class on how do people use statistics, not to lie, but to misrepresent the data. And one of the ways is you just make an exaggerated Y scale. In other words, don't go to 80 or 100, go to 1,000, and all those bars, because they'll be so close together then, vertically speaking, then it looks like there's no difference, when in fact, there's a big difference in the data between where parents and kids spend their time. All right, what did we forget? We forgot to put the index, right, somewhere there, that it tells us which bar goes with the parents, which bar goes with the kids. All right, there's your double bar graph. I forget how many I gave you. It's at least one tonight for homework, but it's not 20 of these, so don't panic. Okay, that's it. Now, granted, the number one thing, and the one that they're going to give you some questions are on tonight for homework as well, is interpreting the graphs. So instead of giving the table, they'll give you a bar graph and ask you some basic questions. You guys should be fine on that. I didn't have any material covering that, but there's just some pretty basic questions. It won't be like, should it have a title? It'll be to read it. So for instance, instead of giving you the table, they'll give you this graph and they'll say, what percentage of kids spend on the web on their computer. You find the yellow bar for kids for web, and you read across, it's 50%. So 50% of their time for kids is spent on the web, not playing games. Did I get that right? No, I got that one wrong. No, I got that right. Yeah, web time. Okay. Any questions on anything I did today? Homework is 1 through 11. All right, that's it for today. You guys have a wonderful day, and I will see you tomorrow.